No. Hello, everybody. Do we have to speak in English, or have we also English people? Yes, so we will do in English. So, hello. We will present you today robotics and remotely operating cutting and the main tools that we forecast to use to dismantle the Brunellis reactor, on which one Bouygues Construction, Nuclear Expertise and Graphitech are currently working. A small summary: we will do a presentation of BCEN. We will present you some specific remotely tools used in dismantling. We will do a focus on cutting laser needs and an extra focus and zoom on the laser cutting tools that we are using, we will use for dismantle the reactor of Brunellis. First of all, a small presentation of Bouygues Nuclear Expertise, even if some already know us. So we are an entity of Bouygues under Civil Work Bouygues Company. And we are performing specific activities like ventilation, civil works, and dismantling. We work for dismantling department. In BCN, we are 1,050 employees. We have a large team of experts and a turnover of 150 million. We mainly work in France and in Germany. We also have a site in Italy where we are working for the Commission, the European Commission. More or less, our activities are close to customers' needs, EDF, CEA, and Orano. So we have, for instance, big agencies in La Hague to do nuclear maintenance for Orano. Our main experiences are engineering to support our works. We are not doing specially engineering. We do engineering to support the work sites that we will do. In civil engineering, maintenance, remediation dismantling, and electromechanical and concrete dismantling, radioactive waste management and conditioning, resin on special products in order to give a specific, to answer to specific exigencies. And of course, we are doing the radio protection for the activities that we will do. C'est toi. I will pass the micro to my colleagues, Manuel Sabos, which is the boss of the dismantling studies in Bouygues.
Hi, everyone. So first, we're going to show you two examples of a specific remotely operated system by a contract we have nowadays since 2022. So it's in Brunellis for the preparation of dismantling of Brunellis reactor. In that contract, we are in a consortium with two entities, two partners, Cléo and Amtech. Cléo is in Bagnols-sur-Cèze and Amtech in Normandy. So just to give you a bit of context before to present you the machine, I don't know if everyone knows how is made Brunellis. So Brunellis, it's a heavy water gas cooled reactor. It has been built in 1967. The final shutdown was in 1985. Since then, the dismantling started. So today, the reactor block, it's almost empty. Just remain the reactor. So the hardest work to do. So here you have a view of the reactor. You can see the scale with during the construction. So the diameter of the vessel here in blue, it's approximately 5.5 meters of diameter. So today the reactor is empty. You don't have fuel anymore, but you still have the plugs in each channels. So the reactor has 216 channels. So that means it remains today 432 plugs to take off. Here you have a view of the loading front. So the particularity, it's a bit like G1, G2, G3 in Marcoule. It's an horizontal reactor. And the particularity was that they were able to reload, to recharge the reactor during operation. They didn't need to stop the reactor for loading the reactor. So now that you have a view, I present you the first machine that we are designing and building. So I don't have the photo of the machine yet because it's in construction. So that one, it's in a Cleo workshop. So they have the part in the workshop nowadays, but it's not assembled yet. So you have a 3D view. So here you have the plug. So the plug, you have two shielding parts, one thermic part and one part we call sword. The sword, so here you have the loading front, and the sword was close to the fuel. So that part today it's activated, and it's where we find the biggest dose. So the machine is made to be installed on the historical platform loading platform, and we're gonna plug one by one on the channel, and the machine is made with here a chain and a tool to clamp the bottom of the plug to pull off the internal, the plug. And here you have a kind of shielding box to protect the operator with the sword. Here we're gonna cut the sword, put in a 5 meter cube box, pre-concrete the sword, and the rest gonna be take away to be treated in another airlock in the sealed sheath here. So those parts you can take off and take away. So that's the first one that we made with Cleo today, and for the moment it's a good achievement, and normally we're gonna start to use in 2 years, next year or in 2 years. The second one, it's really to prepare the future dismantling of the vessel. So that one, it's made to cut in 5 accurate positions each channel. So we have two cutting here near to the vessel bottom, and one cut in the middle. And that is for the future dismantling of the vessel, where another robot made by my friend from Graphitech, his robot gonna take each channel and take them away to a, yes, it's another story. So for this machine, with Amtech, we developed a specific tools for that one. We choose the plasma process for several reasons that I won't develop here, but the plasma was more appropriated. So it's an orbital tool cutting, able to get its sign of each channel, and just to give you an idea, the diameter, it's 95 millimeters. So the challenge was quite huge to make inside an orbital tools and to able to cut. So that was the first challenge. The second challenge was, as I said before, the precision of the location of the tools. So if we cut, if here we don't have the good position, after you won't be able to take off the channel, and the same here. And then the third challenge, where we send the plasma cutting, we do the orbital, but are we sure that we cut what we have to cut? And that, so Amtech developed some control system to be sure that the part is cutting. Regarding that, here we have a quite big thickness of steel, and here the particularity is we have a multi-layer. It's not just one tube; it's several tubes inside and some. Yeah, it's a bit complicated, but So 3 big challenge for that, and the same, the machine is under construction nowadays in the workshop of Amtech, and that we're gonna use after the first machine. Yes, that I can say. Our first challenge at the beginning, plasma cutting, normally it's not made to drill. When you start a cut, normally you have to start a cut from the bottom from the side of the sheet steel to let the plasma goes away. It's very difficult to drill with the plasma because the time we drill the material, you can burn your tools. So at the beginning, we plan to implement a tool, a specific tool to drill first, like a drilling machine conventional, with the same challenge of 95 degrees. But Amtech, yeah, with his knowledge and his skills, since okay, maybe we can do something. He made some development and bought a special plasma machine, and well, it's a bit secret, but finally he managed, especially for those parts where we have a big thickness, to drill first with the plasma without to burn the tool and be able to cut that part. So we sweat a bit for those development, but we managed to do it.
We burnt a lot of tools at the beginning, but no, the characterization for the cutting are quite okay.
Now I'm gonna start to talk about laser cutting. So laser cutting, since 5 years, we got some demand, some needs from our client to make hot cutting with a remotely system. Here's some example of a project we looked, we studied, more or less we studied. We answered some tender, etc. So we have a heavy component PWR, of course Brenelis, as I told you, and we also worked on the Ignalina steam drum, so it's in Lithuania, and they launched a tender to dismantle this big drum. It's the equivalent of exchanger for it's the same kind of reactors than Chernobyl. And from this observation, we said, okay, we have to do something. We were in front of large thickness and singularities to cut. We needed a remotely system, and we have to consider that gradually you change your environment, because of course if you dismantle, you change your environment, and sometimes you have a risk to modify the structure. So all those constraints, we have to consider it. So the laser was really the most appropriate technology, because with the laser, it gave us the high performance of cutting, the speed, is able to cut a large thickness, and the multi-layer, as I said before, multi-layer of material, it's not a problem. You're gonna cut everything. Then the laser avoid the stress and vibration on the robotic arm. I'm sure that most of you know that the problem generally is not the tool, but it's the arm, because if you have a conventional tools like a saw, you make vibration, and generally it's your arm first that you have to maintain. It offers also the flexibility of cutting position. With laser, contrary to plasma, you can have a distance. You don't have to respect a specific distance of the material. You can be very close, and 10 centimeter, 20 centimeter, it's okay. If you adjust your head, you're gonna manage to cut. You don't need to clamp the part you are cutting, so that's also an advantage. So Sometimes you have to hold the part to avoid it to fall, but for the cutting process, you don't need to be clump. So that it's another advantage. And finally, you can cut a wide range of material, not just steel. You can cut concrete, you can cut isolation, everything. The laser, okay, it's gonna be separated. So from that, we decided 5 years ago, okay, we have to develop something. Bouygues and Graphitech has to be present on that area. So we decided to develop on two main areas. So to design specific tools that they are in the box, and you can visit our stand after. So we broke the two laser head I'm going to show you after. And it's not to give a tools to our clients, but after it's how do you use it? Because the tools, it's not the difficult part. The difficult part is to bring the tools in a high radioactive area to manage the fiber, to manage the harm, to implement all the system. And here you have the engineering. So as you understood, the laser cutting, it's a Breton aspiration. You want to see?
It's a Breton inspiration because since 30 years, Bouygues is working on a Brenny's site. And you will see after, but we find a partners, a research partners based in Brest, who is used to work with laser for the conventional industry. So when we have identified these partners, we begin to discuss with them in order to develop a flexible and fiable, reliable tools in order to can use it in dismantling. We will show you after a small video of the activities that we are doing currently in Brunelis. But our idea is to develop this technology with the competencies available in this region.
Yes, so it's really a French Breton technology because our partner is mostly in Bretagne. All the metal company and usineur, sorry, I forgot the word. Here is just a photos of the exchanger of Brunelis that we dismantled 10 years ago. So it was
that we dismantled at this time with wire saw, but we imagine also that instead of wire saw, the laser cutting tools can be a good technology to cut the tank and all the equipment that are into, and all the small tubes.
So just to remind you, what is the laser? The laser means light amplification by simulated emission of radiation. So the principle, you have a laser resonator who give you a large amount of light energy that you transfer by a fiber, pass through a lens, and you focus the energy on a specific point who get melt the material. So, and you send a laser gas. Its function is to maintain the low temperature of the head and to blow the material to allow the cutting line. So you can adjust a lot of parameters, a lot of criteria on this technology. One of the main one is the focal length. So you can have a short focal to get a short laser beam. That usually it's what they have in the industry, where they have a table and they want a really clean cut, but it's not what we want in the dismantling. In the dismantling, that it's okay for us. I don't care about the quality of the cut. I want to separate my material. So we're gonna take a lens who's gonna give us a long focal to have a large laser beam. And to be more flexible with the distance I was talking before. the main risk is that the energy remains focused a long distance behind what you are cutting. So don't pass behind, because you're gonna be... But it's a risk that we have to consider it, of course, and you can't implement laser as you want. We have to, of course, to be a really restrictive environment and control when you get in or out, etc. So here the stuff. Here it's the first laser head that we developed to answer to the needs of what I showed you before. Ignalina, the big component, Brennelis. We hope that laser head gonna cut 80% of the structure of Brennelis. We will need other head that we have to develop, but that one, it's really made for decommissioning. It's a robust and rational design, compact size, inexpensive manufacturing. That one we will be able to consider it as a consumable. Like if we broke it, if a piece broke, or if we punch, damage, it's okay, it's not a drama. Just the fabrication is really not expensive. What is expensive is the engineering. Again, it's really the engineering around. And we have, it's a free, effluent-free process. We don't need liquid to maintain the temperature. It's only by a gas. And we don't have electronic on board. So we really think that head for the decommissioning. We developed that with the Institut Maupertuis in Rennes. Institut Maupertuis, just a few words on them. They are specialized on the laser, especially the welding. It's a non-profitable company. Their aim is to help a company like us to develop projects like that. So we have a special partnership on that, of course, and some protection. I let you read the rest of the specification, but it's qualified today. This year we're gonna make some other trial to really qualify the high performance. Voilà. I give you the last slide for my colleague Suleiman from Graphitech.
Okay, thank you, Manuel. So 1 year ago, I'm Suleiman from Graphitech, and we are involved in the dismantling of the reactor of Brennelis, especially the phase of removing all the channel tubes from the vessel. But for that, I invite all of you tomorrow at 11. We have a workshop dedicated on this robot. 1 year ago, so like I said, 1 year ago, we had a need in cuttings to separate all the channel tubes from the vessel, and the point in Brennelis is that we are very constrained by the space. It's a quite very narrow area. We deploy our tools from little balcony in each side of the reactor, and also around the pieces that we have to cut, there is some pieces that we don't want to touch, and that means no technological cutting on the shelf are available for that. And we discuss with several institutes, and we launch a tender, and Bouygues won the tender, and they developed a dedicated head, laser cutting head, able to move the focal point. Two things in laser cutting: It's the focal point, where is the maximum of energy, and the ability to blow the melted iron, melted steel. And for this configuration, the idea was to move the focal point to something very far in order to keep the head, the cutting laser head, outside of the structure that we have to remove.
So just that one, with I was talking before, the focal point, that one is the most dangerous, because the focal point is very very far, and so the energy remain very concentrated on
far
a
away.
very long distance.
Yeah. So we managed the SAT, the FAT, sorry, factory acceptance test in May this year, and it was concluded. It was okay. All the tests were the specification we done on the consultation, and now the head is on our hand. We need to integrate this head in a very full system in order to, like I said, remove all the channel tubes. That's it. Something to add?
Just maybe about the name of the head. If you were wondering what's that, as I said before, we wanted to make a tribute to Bretagne region. So the first one is called Ménézaré, so it's a mountain in Bretagne, and the other one also. We decided that all our laser head will have a name of volcano or mountain. So the two first one got the name of Bretagne mountain, and the rest we'll see. Maybe we call one Everest or something more. Voilà. Thank you for your attention. The two laser heads are here. You can take in your hand. It's okay. And if you have any question, we make you a pleasure to answer.